We're going to be talking about extending tools like jsPsych and JATOS, which are open source web experiment tools. So I'm not going to talk a huge amount about what those are. I'm going to assume a little bit that we know what these tools are. But a brief primer, jsPsych, as Becky said, is a JavaScript library that allows you to run web experiments in the browser. And JATOS is the server, the web application framework that allows you to host those web experiments. So the participant will connect either directly to the JATOS server or maybe via Prolific or mturk to the server. And the server will will use that information to serve the participant one of your experiments. Okay, so JATOS and jsPsych, being open source tools, are so being open source tools, they have a couple of pros. So the most common things that you want to do are probably available in these tools because everybody wants to do common things. And as such, you're likely to have one of those people who got frustrated with the lack of that common thing not being available and coded it up for you. So jsPsych, as an example, has all these plugins like this like art survey. Everybody wants to do like art surveys. So this plugin's here and you can just use that in your experiment. Sometimes weirdly specific stuff is available as well. So jsPsych also has this plugin that was created apparently to replicate the methodology of this 20-year-old study here. So if you wanted to replicate this 20-year-old study, you'd be in good company. There's a plugin for that. More commonly though, if what you want to do is a little bit unusual or it's difficult to implement, you're unlikely to have these sort of plug and play solutions because it's not going to be available at all, or it's not going to be in the right format. And if that's the case, we're going to talk about how to solve that problem. So this is the open source lament, almost the thing that you want, but not quite. So if you have the problem, almost the thing that you want, but it's not quite there, like many of the demos that Becky talked about earlier, there are a few ways we can go about solving this problem. Now, the first one is to cobble together bits of the existing toolbox to do what you want. So as an example, I was using, as Becky said, her image audio plugin to do a Stroop task, but it wasn't showing my stimuli correctly. I was changing the height and it wasn't maintaining the width, it wasn't maintaining the aspect ratio. So I needed to fix that. Fortunately, there was another plugin, the image keyboard response, which did have this maintain aspect ratio feature. So all I needed to do was go into Becky's plugin, the image audio response, and copy and paste those two blocks of code into the image audio response plugin. And now my stimuli appear beautifully. So like I said, open source tools, the most common things you want to do are probably already available. If not in the plugin you want to use, probably somewhere else in the toolbox, and you might be able to cobble those things together. Sometimes you can't do that though. Sometimes what you want to do is not available in that plugin or in another plugin in some part of the library. And in that case, you have a couple of more solutions you have before you want to throw in the towel. So one thing you can do is create a brand new plugin, code the thing from scratch. Open source tools make this pretty easy to do. So jsPsych has some documentation. You just copy this block of code here. That gives you a plugin that does nothing. And you can make that plugin that does nothing into a plugin that does exactly the thing that you want. So we saw some examples of that earlier. Lydia did that for her sliding response to moving dots. So that's one solution. But of course, we don't want to code from scratch if we can avoid it, because it's a pain for a lot of reasons. It can be quite difficult. It can be often very time consuming. We might lack the necessary expertise either in the language or in trying to implement the particular thing we want to implement. We might be lazy. There are lots of reasons why we might not want to code something from scratch. So if that's the case, we do have one more solution before we have to code from scratch. And that is band-aiding a tool from a completely different toolbox or a completely different language on top of our existing toolbox. So that's what we're going to talk about here. So one of the things I wanted to do was do some moving dots. So get some dots moving on the screen. Participants classify the direction of the dot motion. That's a pretty common thing to do. JSPsych has a plugin for that, so that's good. What's uncommon is that I wanted to do some psychophysics. So you saw a lot of people, they wanted adaptive training. Psychophysics is one way we can do adaptive training to titrate the difficulty of my experiment to the participant. And that's a pretty difficult operation. It involves fitting a psychometric function, a sine curve like this, to the participant's performance so that we can get estimates of how they're going to do. It's pretty complicated mathematically, and of course, JSPsych doesn't have a plugin for this. So I could code this from scratch if I wanted to, but I didn't want to do that for a couple of reasons. The first is because trying to code a psychometric function estimation in JavaScript sounds like it's going to cause me a great deal of physical pain, but also, and this is the reason that I'll probably write up in my PhD, because psychophysicists are really enthusiastic about making sure they can control everything as much as possible in their experiments so they can get the highest possible fidelity on the intervention, the effect that their intervention is having. So they'll control the light levels in the room, they'll control the screen luminance, they'll control the external noise, all these factors. Obviously, with web experiments, you can't do any of that. You can't even make sure that the stimulus appearing on the screen is exactly the same from participant to participant, because there's only so much information we can get about people's computers. So I'm not going to let that stop me from trying to do psychophysics, but the least I can do is use a robust peer-reviewed package that's going to account for some of this variation much better than, you know, whatever half-baked optimistic method I end up cobbling together in JavaScript. And there is a toolbox for this. We have signeyfit. Signeyfit is a peer-reviewed psychometric function estimation toolbox. It's something I use in my MATLAB version of this experiment, and it has a Python version, which is a good thing because it means I can, well, it's a bad thing because it's not in JavaScript. So I can't just plug it into my JavaScript experiment in JSPsych, but it's a good thing because it's in Python, and that means that I can band-aid it on top of my JavaScript experiment. So I'm going to walk you through how I did that. So the first thing we need to know about when we're doing this is HTTP requests. So HTTP requests are how online entities communicate with one another. So JATOS will use a lot of HTTP requests to communicate with the participant's computer, to communicate with Prolific, and the participant will communicate with HTTP requests to the Prolific website or the mTurk website. So we need to create an HTTP request connection between our JSPsych experiment and signeyfit. Now, it occurred to me as I was writing this presentation that it's very possible I could get JATOS to do this. JATOS already does a lot of HTTP request stuff. So maybe I could have gotten JATOS to do this. Obviously, I didn't know about that when I was learning all this stuff, so I didn't know that that was even a thing. And in fact, it highlights one of the, probably the key takeaway from this talk, which is where to go for support. So JATOS is a web experiment tool written by web experimenters, and they're going to solve the common problems that web experimenters have. What we're now doing is not so much web experiments as web development, right? We're trying to extend some web development tools, our web experiment. And so maybe the kind of problems that web experimenters have are often very different to the common problems that web developers have. And so, as an example, when I went into JATOS to figure out whether I could do this for this presentation, I found some information on how to do HTTP requests, but not really what I wanted. And that's because, in this case, the web experiment community, this open source toolbox and the support there, is not set up to solve web development common problems. So what I want to do is not go to the web experimenters to help me with this. I want to go to the web developers. And when I did that, I came up with Axios. And Axios is an HTTP client that you can pull into any JavaScript experiment or JavaScript library to help you make HTTP requests. It has fabulous documentation and it has fabulous support. And I'll show you how easy it was for me to pull it into my JavaScript experiment. So this is a mock-up of my JSPsych HTML file. And just as we pull in the JavaScript libraries in the header of our experimental script, we pull in the Axios library. Now I'm pulling it in from online. That assumes that the participants are online. If you were assuming that your participants were offline, you might have to do it slightly differently, but it's going to be similarly easy. So I pull it in. I use the JSPsych functions to tell the participants to wait while I pause the experiment. I put the data into a variable that I can send off somewhere else, and then copied and pasted from the Axios documentation, I have this. So I'm telling Axios, hey, can you send to this URL using a post HTTP request, the variable that I created early, and hey, why don't we authenticate that with a username and password? And then Axios is going to wait for that server to do what it's going to do. It's going to get the response from the place it sent it off to, and then I can use that in this variable later on after I resume the experiment. So it was as easy as that. So now I have JATOS running my jsPsych experiment, and it can communicate to the outside world. So now we can proceed to get signeyfit set up to communicate back. And for that, we need a web application framework that's compatible. Now, a web application framework, as I said before, JATOS is an example of this. It's something that receives instructions, it runs programs within it, and it sends those, and it does, and it serves those to the world. So we need the equivalent of JATOS with our jsPsych experiment for signeyfit. We need a web application framework. Now, again, it occurred to me that JATOS might be able to do what I wanted to do. But again, another example of going to the right community for support. So JATOS is really, really good at serving web experiment toolboxes that exist, like jsPsych, like lab.js, OpenSesame, these sort of things. But if you want to do something other than what web experimenters commonly want to do, it doesn't provide a lot of documentation. So what you want to do is go into the web development world and say, hey, I'm trying to band-aid these things together. How do I do that? And you're going to find a lot of really well-supported web application frameworks that are going to be much easier to use than trying to make JATOS do what you want to do. So Laravel is an example of it. It's for PHP. So if you had a PHP script that you wanted to band-aid on top, you might use the Laravel framework. signeyfit, like I said, is in Python. So I'm going to use a Python framework, and I came up with Flask. Flask is a lightweight Python web application framework. And as you can see in the documentation, it's designed to make getting started quick and easy, which is exactly what we want. And it really is quick and easy. So I'll show you my setup. But the important thing about Flask is it's well supported, and it solves all of the common problems that I ran up against when I was trying to do this band-aiding solution to my JavaScript experiment problem. So anytime I Googled some random problem I was having, there was lots of support because I was trying to do web development, and web developers solve the common problems that web developers have. All right, so this is my script. I'll just run through it very quickly, and you'll see how straightforward it was. So we start off by saying, from Flask, import the Flask core library, import the plugin request, which is our HTTP client, and import two other plugins that I'll talk about shortly. Here I'm importing some other packages that are important for signeyfit that I got off the signeyfit documentation. I start up the application, and now here what I'm doing is I'm saying on the home page, let's say dorianminors.com, I want you to serve this HTML file. Now I was doing this with the render template plugin that we pulled in earlier. And it's 3 lines of code that allow me to serve a script on a page. Now, you could use this to serve your JavaScript experiment, theoretically, because your JavaScript experiment is essentially a website. So, of course, web developers, they like to serve up websites. So, of course, Flask has this functionality built in, and of course, it's really easy to do. Now, like I said, I was just using this for testing, but I could potentially run my experiment just using Flask. Okay. The next thing I do is set up another route, this time on the URL signeyfit, so dorianminors.com/signeyfit. And now here I'm listening for post HTTP requests because remember our JavaScript experiment is ready to send a post HTTP request out. And I say, once you get that information, do this function, get the JavaScript information, pull a particular data array out of that information. Here are some of the options from signeyfit. So I say set up signeyfit, and send the options and the data to signeyfit and get the result. And then here's the third package we pulled in. I'm going to get the result, but it's going to be in Python. And I want it in JavaScript because jsPsych is a JavaScript library. So I JSONify it, I make it into JavaScript, and I send that back to where it came from. And that's it, 30 lines of code. And we have our signeyfit package set up just as we have our jsPsych experiment set up. So this is what the architecture looks like now. The participant comes in through prolific, hits the JATOS server, which serves up the jsPsych experiment. At a particular point, it communicates to signeyfit, gets the information back, and continues on with the experiment, and the participant is none the wiser. We're going to skip this because I don't have time. Okay, so if your problem when you are doing your web experiment is that you have almost the stuff that you want but not quite, which is a very common problem to have, there are 3 ways that we can solve this problem. The first way is to cobble together existing pieces of the tool that we're using. We can also code something brand new for the tool. Or we can try and band-aid with a completely different tool, maybe in a different language or a different library in the same language. If we're going to do that, we need to find a tool we can use, right? We don't want to recreate this problem where we have almost the thing that we want. We may as well try and find a tool that's very close to what we want. Find a web application framework that can run that thing, like JATOS or Flask or Laravel, and then get them communicating to one another using an HTTP client. And if you're going to do this band-aid solution, keep in mind 2 things. That the web developer community is way bigger than the web experiment community, and so they're going to be solving the common problems that web developers have. And web experiments are essentially web development, so it might be a good place to go for support. And when you're looking for support, make sure you find the most popular programs that web developers are using, because they're more likely to have the answers to the random problems you're going to come up against. All right, thank you. That's it.